All right, you guys, today we are looking at power functions and then we will look at function transformations. So power functions are another type of function and they are of the form x to some power where that power is a constant. And we can break power functions down into two different cases, even and odd functions. Other functions can be thought of as even and odd, but power functions in general are just a good example of that. So with power functions, we've got even first, and you can think of a function like x squared. Okay, so even functions have this trait where they're all symmetric about the y-axis. Okay, so one of the ways we can test for even functions is by plugging in negative x. Okay, so if I can plug in negative x and I can get back my original function, then it's an even function. So if we were to try it with x squared, okay, so I'm going to plug in negative x, should be negative x squared, and that's going to give me back x squared, because you can always think about it, negative 1 squared is 1, so that's one way to think about it. The other thing with even functions is that each y value is going to have two x values. Okay, so for every y value, let's say y equals to 2, if I were to look at x squared, I would have two x values that match it. And that's okay. Repeated y values are okay. It's just repeated x values that are not okay. Okay, so that's with even functions. The other case we have would be odd functions. So an example of an odd function would be like x cubed. Okay, so it'll have kind of this basic shape. All right, and so this should be odd function. Odd functions are symmetric about the origin. Okay, so if I were to take this function and rotate it around the origin, it should line up. Okay, another way we can test for odd functions is if we've got, let's say we've got f of x is equal to x cubed, that's our function. Now if I take and I plug negative x in, it should give me back the negative of my function. So if I plug in negative x into x cubed, that's going to give me back negative x cubed. Because if you think about it, negative 1 cubed is going to be negative 1 times negative 1, which is positive 1, times negative 1 again. So it'd be negative 1. All right, when that's negative f of x, my original function. So that's our test for odd. Now, something to note, the leading exponent does not guarantee even or odd. So with these two examples that we looked at, yes, that worked like that. Because we were only looking at, there was only one term in our function. But if we look at a function like x cubed plus x squared plus 3x minus 1, we don't know whether that's even or odd until we test it. Okay? All right, some other power functions are x to the 1 over n. Now, with x to the 1 over n, remember those are our roots. And that can be broken down into two cases. We either have where n is even or where n is odd. So it'd be like square root versus cube root. Okay, so where n is even, it would take this basic shape. Okay, so that would be something like x to the 1/2. All right, and where n is odd, it would take on this basic shape. And that'd be something like x to the 1/3. Okay, so those are our roots, our root functions. Okay, and then the last case we'll look at is if we have x to the negative power. Okay, and that again is broken down into two cases. N is going to either be even or odd. Where N is even, be something like, we'd have x to the negative 2 maybe. And if N is odd, it might be something like x to the negative 3, and it'd take on that basic shape. Okay. All right. Now, so those are just kind of the basics. When we're looking at functions with two variables and we want to figure out whether or not they're symmetric about either the y-axis, the x-axis, or the origin, or not at all, there's three, so it breaks down into the three cases. So let's say we want to check the x-axis. If we want to see if our function's symmetric about the x-axis, then we'll leave x alone, replace y with the negative y, and simplify. Okay, and if we get back the original function, then that means that it is symmetric about the x-axis. The y-axis is similar, except for we replace x with negative x. Okay, and then with the origin, you replace both of them. And with all three of these cases, your goal is to simplify it and see if you get back the original function. Because if you get back the original function, then that means it has that symmetry. Okay, so let's try it with this example. We've got x squared plus y squared equals 1. So let's test for x-axis symmetry first. Okay, and so that means I'm going to leave x alone, and I'm going to plug in negative y. And negative y squared is going to be just y squared. And so that gives me back the original, so yes, it's symmetric about the x-axis. Y-axis symmetry. Okay, we'll put negative x in for x and leave the y alone. And negative x squared will give us back x squared, which will give us back our original function. So yes, it's symmetric. Okay, and then lastly, if I take and I plug negative x in for x, negative y in for y. So I'm testing for symmetry about the origin. All right, negative x squared is going to give back x squared. Negative y squared is going to give back y squared. And that is my original function, so yes. Okay, so this function x squared plus y squared equals 1 is symmetric about the x-axis, the y-axis, and the origin. Okay, and so this function is actually a circle. Okay, this is as close as I can get to a circle. But you can see why that would be symmetric about all three. Okay, now if the function only has one variable and you're plugging in, so if the function only has one variable, so something like f of x is equal to x squared, okay, there's only one variable in that one, then plug in negative x in for x, and if you get the original function, it's symmetric about the y-axis, so that test stays the same. And if it's negative of the original function, that means it's symmetric about the origin. Okay, so the origin test is a little different if your function just has one variable, but it's not that different. Okay, so there's our symmetries. All right, so now we're going to talk about some transformations. So if I've got a function, so we've been talking about these common functions, or the functions we've been using have all been kind of a common shape. So we can shift them around by adding or subtracting a constant. So if I add or subtract a constant on the outside of the function, okay, I'm going to shift it up or down. Okay, so if I have a basic function, so my basic function for this case would be x squared. So that would be just the parabola that goes to the origin. And this +2 means I'm going to shift it up 2. So all of the points get shifted up 2. Okay. And if I'm going to subtract 2, I start with my basic, goes to the origin. And if I'm subtracting 2, then I'm moving down 2. And so all of the values get moved down 2. Okay. So that's up or down. If we are subtracting or adding inside the function, okay, so in this case, our basic function is x squared, but that x has been replaced with x plus 2 or x minus 2. Okay, so that would be considered inside the function. And if that's the case, then we're moving left or right. And in this case, we do opposite. So if you're adding, so let's start out, I've got my basic. Okay, if I'm adding 2, that means I'm going to move to the left 2. Okay, so all of the x values get 2 subtracted from it. All right, now if I'm subtracting 2, all of my x values are going to get 2 added to it. So I'm going to move to the right 2. Okay, so it's for shifting left or right, any of our horizontal movements, there's going to be the opposite of what you think. Okay. We can do some other transformations or a combination of these translations. All right, so when we do this, we're kind of going to start off with a parent function. We want to identify that first, and it'll generally be one of these cases, either a constant, so just a horizontal line, or a line, just basic line. Could be a quadratic or a cubic, square root, cube root, a rational function, or an absolute value. Okay, but it'll have that basic shape. And then in addition to shifting up, down, left, or right, we could do a stretch. So a vertical stretch. So if we're multiplying by a function by a constant on the outside of the function, so if we're multiplying by 2, and that's outside of our square root, it's doing a vertical stretch by 2. Okay, so all of the y values will get doubled. So if we start off with just a regular square root function, all of the y values get doubled. So we're stretching it all up. Okay, the opposite would be a vertical compression. So the way to know the difference between a stretch and a compression, a stretch, your value that you're multiplying the function by is going to be greater than 1. And compression, it's going to be less than 1 and greater than 0. Okay, so if we're multiplying it by 1/2, then we're doing a compression. So all of our vertical coordinates get compressed by 1/2. All right, we can do the same thing horizontally. So horizontal is always going to be inside of the function. Just like up here when we added or subtracted, our horizontal movements were inside the function. Okay, so our compressions and stretches, that's also inside the function. All right, and again, horizontal, it's going to be the opposite of what you think. So if we're multiplying it by 1/2, that tells us we're doing a stretch by 2. Okay, any of your fractions, that's a horizontal stretch by the inverse of whatever value you had. Okay, so that would be, for example, if we had our basic square root and we're doing a horizontal stretch by 2, all of your x values get stretched by 2 or get multiplied by 2. Okay, if that value that you're multiplying it by is greater than 1, so in this case we had 2, that means we're doing a horizontal stretch by 1/2. So it's getting horizontal compression by 1/2. okay? But it all gets compressed by a half. So if there was our original, everything would be compressed to a half. And then lastly, we've got reflections. So if we are multiplying by a negative outside of our function, that tells us we're going to do an x-axis reflection. Okay, so if this was our original, we're going to reflect it about the x-axis. If we are multiplying by a negative on the inside of our function, that's a y-axis reflection. Okay, so if this was our original, here would be our reflected. So just flipping it across the y-axis. All right, so you can do, a function may have multiple of these transformations. Okay, so you're going to want to do it in this order. Make sure you identify the parent function. It should be one of those that are on this list up here. And then you're going to look for any stretches or compressions. So are you multiplying it by anything? Then look for reflections. Are you multiplying it by a negative anywhere? And then lastly, any shifts. Are you adding or subtracting anything? And just remember, horizontal changes our inside and you do the opposite of what you would think. Okay? Now, if you've got questions about these, you can ask me in class. I should have in the module a list or a handout with the basic functions and their graphs, okay, and then a table with all our transformations in it.